Alright guys, so here is the second part of covalent bonding continued. What you'll notice is we've got our two examples there for the ones we've already done. And I've written all of our prefixes. You were given this in a handout with ionics. It's there, I promise, but I'll remind you where it is later. So for example, we call these prefixes because all of these words go before an element name. So for example, okay, if we have one element, we call it mono something. 2, di, tri, tetra. Notice 2 is di and not bi like a bicycle. 4 is tetra and not quad. And 7 is hepta, not septa. Those are going to be the three changes to what you're normally used to when it comes to numbers in math. All right, so we're going to go over here and we're going to just name these. And I'm going to show you just how simple naming can be with covalent compounds. All right, so I'm pretty sure that all of you will look at that and you'll tell me that's carbon dioxide. So I'm just going to write it. I'm not even going to explain it. I'll come back. All right, and some of you would tell me that that's carbon monoxide. So now let's look at these two really quick. Okay, so notice just like before with ionic compounds, there's the first word completely written out. Here's the second word, and it's changed the ending to IDE, just like here, carbon and oxide. So you know that your compound contains carbon and oxygen. Carbon, oxide, carbon, oxide. Notice the only difference is the prefix. This one has a 2 or a di, and this one says mon. Because this one has 2 oxygens, so dioxide. This one has 1 oxygen, so it's monoxide. Notice though that both carbons, the first element in the first position, just like before with positions, the first element in the first position, if there's only one of them, we don't say monocarbon dioxide. We just say carbon dioxide. Same thing with carbon monoxide. So if there's one element in the first position, you just name it the way it is. Okay. Now, if that element in the first position has a number, now we bring in the numbers for it. And we would say that this, looking for the 2, is di again. So we would call this dicarbon. 3 is trioxide. So notice again, we have the name carbon, we have the ending oxide, we have the numbers now associated with both of our subscripts, a di and a tri. So there's di, there's tri. And again, they are prefixes, so they go before the element, even though the number is after it when it's written in a formula. All right, and then the last one, this one's I'm going to try to trick you on this one. Okay, try to see if you can name it. I'm going to give you a second. Pause it if you want to. All right. 4, again, is tetra. So we would call this one tetracarbon. And then, how many S's do we have? We have an understood 1, right? So if that understood 1 is there, we still have to put a name for a prefix on this element, no matter what. Okay, it's not in the first position, it's in the second position. The element in the second position must always have a prefix. Always. And in this case, it's mono. So we would call this one monosulfide. Okay, normally sulfur, change the ending to "ide", and then we have our 2 prefixes. We have a tetra and we have a mono. All right, so tetracarbon monosulfide. So that's how we name these. And then writing them is exactly the opposite. So for example, if I said, oh, let's do tetraphosphorus pentachloride. Okay, tetraphosphorus pentachloride. So we have our prefixes of the tetra and the penta, and we know that our elements are phosphorus and chloride. or in chlorine. So you can write it this way in the beginning if you want. You know that that's a 4, you know that's a 5. This is P and this is Cl. The problem is if you'll notice, the numbers don't go before the letters when you write them in the formula. So you have to rearrange things a little bit. Okay, so in this case, if you were to write the actual answer, the answer for this, if you want to pause it before I put it, do it. Pause it and try it on your own. It really should look like P4 and then Cl5. And that would be tetraphosphorus pentachloride. All right, we'll try a few more. Okay, so now let's go from the beginning to the end. So for example, if I gave you 2 elements, I said what would happen, or what would N and F look like if we were to name these and put these into a drawing and write the formula. So I'm going to want you to draw, name, and write the formula. Write formula. All right, so here we go. If I put an N and an F together, you know what? Let's do this so that you can see the difference in the 2 elements. Let's do N in one color and F in the other color. All right, so N. I'm going to write N first, and I'm going to look on my periodic table, and I'm going to say, okay, N. N is in group 15, which means it has 5 dots. So I'm going to write 5 dots around N. 1, 2, 3, 4, 5. Now, in the last video, I told you guys, everybody wants 8 electrons. Nitrogen has 3 electrons. So technically what your brain should tell you right now is that you are short 3 electrons, which means you should want 3 bonds because you need to get 3 more electrons to share with. All right, and I'm going to do an F here. 1, 2, 3, 4, 5, 6, 7. So I should have done it 1 on each side. All right, so 1, 2, 3, 4, 5, 6, 7. 7 dots because he's in group 17 and only needs 1 more. All right, so that should tell you that F is short 1 electron, which means he wants to make 1 bond. So let's make the fluorine bond once. Okay, so he's going to bond here. There's 1 bond. Fluorine is now happy with 8. 2, 4, 6, and remember 2 electrons in a bond is 2. So that's 2, 4, 6, 8 electrons. But now look at nitrogen. 2, 4, 5, 6. It's made 1 bond and it got an electron, but it's not enough. So it should make 2 more bonds. So I'm going to put an F here and I'm going to put an F here because I think you guys are going to see that if I do that, the one that has a little bit more space. So 1, 2, 3, 4, 5, 6, 7, and then another F here. 1, 2, 3, 4, 5, 6, and 7. Notice I'm putting my bonding electron closest to nitrogen just so that it looks prettier. Remember, you don't have to do that, especially when you start drawing these. You don't really know. Okay, and then there, and then those 2 bond. Now, if I do this, each fluorine has 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Now look at nitrogen. Nitrogen has 2, 4, 6, 7, 8. Everybody has 8 electrons. Like we said, nitrogen was going to make 3 bonds because it needed 3 more electrons. And each fluorine makes 1 bond because it needs 1 more electron. Now this thing up here, for those of you that are going to be taking AP chemistry, I'm going to mention it. We're going to talk about it later if we get to talking about our shapes. These things here are called our lone pair electrons. Okay, so that's a lone pair. They're all by themselves. They aren't bonding, so non-bonding electrons. And they have a lot to say about what happens to the compound when it comes to shapes. So, for example, not that you need to know this right now, like I said, but because of those electrons, and we all know that electrons repel each other, what's going to happen is in a three-dimensional model, it'll look something like this. And these molecules will actually then, in the end, look more like what we would say a three-dimensional model, okay, because of that. One goes into the wall, one comes out at you, and one goes straight back. And then we would, in the end, call this, because there's three things, trigonal. And then because these electrons are pushing everything down away from everything, it's actually going to be called trigonal pyramidal. Pyramad. Pyramidal. Pyr. I can't spell. There it is. Pyramidal. All right. Again, we'll see if we get to naming things or not, but if you go to AP Chem, you will definitely see this again. All right. So now, notice we've done all of this stuff. Technically, this is extra for right now. Okay. Focus on this part right here, the uglier part, in my opinion. Okay. We've written our formula. Notice how many F's do we have? 1, 2, 3. So our formula, so we drew it. Now we're going to write the formula, is NF3. NF3. And now let's name it. NF3. So we have one N. In the first position means we just call it nitrogen. And then we have 3 fluorines. And we know that 3 is tri. So we would say tri, and then fluorine, just like before, in ionics and covalence, we change the ending to "ide." So this is nitrogen trifluoride. Done. Let's do one more. Okay? All right, so here's another one. We're going to do C plus O. All right, carbon, as you all know, is an extremely important element. He's in the exact middle of the periodic table. And because he's in the middle of the periodic table, remember we talked about it, if you were to look at it like a game board, it can go forward 4 or backwards 4. So if we look here, here's carbon, and it can go forwards 4 or backwards 4. But because it's a nonmetal, and we know that it's a covalent bond, in this case, it's going to be considered -4, which means it's going to want to gain 4 more electrons. So because it's going to want to gain 4 more electrons, we all know that number 1, it's in group 14, so it has 4 dots. And just like we said earlier, if it has 4 electrons, that means it's short 4 electrons, which means it's going to make 4 bonds. And now we look at oxygen. Well, oxygen is in group 16, which means it needs 6 more dots. Sorry, it needs 2 more dots. 1, 2, 3, 4, 5, 6. So, here's what we're going to do. Carbon likes to be the center of attention. Oxygen needs 2 more electrons. Sorry, I didn't put electrons. Minus 4 electrons minus 2 electrons equals 2 bonds. Okay, so now if you notice, here's the problem. Carbon needs 4, but oxygen only needs 2. So let's combine where we can. 1, 1, there's 1 bond. 1, 1, there's another bond. This oxygen is now completely content. 1, 2, 3, 4, 5, 6, 7, 8, or 2, 4, 6, 8. Done. That oxygen is perfect. But notice carbon has 2 extra bonding sites. And what did we do before? Well, we said if carbon bonds to something, it's going to probably bond to oxygen. So in this case, we could add another oxygen. And so that's exactly what we're going to do. We're going to add another oxygen. So I'm going to put one right here. 1, 2, 3, 4, 5, 6. It's going to be a little ugly. That's okay. You can even, like I said, move your dots wherever you want if you want to make it look prettier. I took one on the top off. I'll put one on the bottom. And now we have our dots for bonding. So 1 there, 1 there, 1 there, 1 there. And now we have 2, 4, 6, 8 for this oxygen, 2, 4, 6, 8 for that oxygen, and 2, 4, 6, 8 for carbon. Everybody is content. Now, the way I've drawn it, you can't tell the shape, later you'll realize that this is what's called linear equation or a linear shape. So what's the formula? Well, the formula is good old CO2. So you drew it, we wrote the formula, and then as you all know, this is carbon dioxide. All right, I'll do one more. I'm going to give you guys the formula and see if you can go backwards. That's the easiest. No, that's too easy. Instead, let's just keep doing what we're doing. Let me give you two elements and then you draw it. All right, so let's do, how about, ooh, I'm going to trick you. All right, let's do, as I always do, I lied again. Let's do S plus Br, and let's do P and H. Get ready for that one. All right, pause it and start it back when you're ready. Okay, so here's one of our last examples. We have SBr and then we're going to do P and H. So if you look up S on the periodic table, again, S is in group 16, which means it has 6 dots. So I'm going to draw S with 6 dots. 6. All right, and then Br is in group 17, which means it has 7. So Br, 1, 2, 3, 4, 5, 6, 7. All right, so as we know, if this has 6 dots, it needs 2 more. If this has 1 or 7, it needs 1 more. So we're going to share where we can. Those two want to share, which means now we need another Br so that the S is satisfied. 1, 2, 3, 4, 5, 6, 7. Bring my dots close to each other. And now we have, basically in the end, it looks like Br bonded to S bonded to Br, which is really similar to what water looks like. And so the equation would be SBr2, and then we would name this sulfur dibromide. Now, if we wanted to change this up a little bit, make it a little bit trickier, instead of having S in the middle, we could put something like carbon. And that would actually be even a little bit more exciting. So I'm going to change that really quick. Let's change this. Actually, let's just rewrite it really fast. Okay, so there's S. Okay, so I'm going to change it to C and Br. C plus Br. See if you can do that one. I know I just threw a curve at you, but let's see if we can do it. Okay, so separate that out. Carbon is in group 14, which means it has 4 dots. So I'm going to put 4 dots. 1, 2, 3, 4. And then Br, again, has 7 dots. 1, 2, 3, 4, 5, 6, 7. So if you're thinking to yourself, okay, carbon again has 4 dots, which means it needs to make 4 bonds. So there's 1 bond, which means that we're going to need how many more bromines? Good. We need 3 more. 1, 2, 3, 4, 5, 6, 7. Bromine, 1, 2, 3, 4, 5, 6, 7. This is when markers are amazing because you can go so much faster. All right. And then we just connect all of our dots. 1, 2. Now each carbon, or this carbon has 1, 2, so 2, 4, 6, 8. Each bromine has 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, and 2, 4, 6, 8. All right, so this formula would look more like C, then you just put the BRs all around. And then you can put all the dots around them too. 1 carbon, 4 bromines. Notice I'm writing it. C came first, then Br. C is less electronegative, Br is more electronegative, so that's why it's second. And if we named it, carbon tetra is for bromide. All right, last example. Here we go. P and H. Trying to trick you. Okay, so if you'll notice, you have P. He is in group 15, which means he's going to have 5 dots. Anyone notice anything weird about why I put P first instead of H? As always, hydrogen is the exception to basically every rule. Also, in this case, P is more electronegative, so it's going to be in the center versus a hydrogen who is not going to be, because we can tell P is going to need to make 3 bonds. Whereas if you'll recall, hydrogen only has 1 dot. Hydrogen is in the first group all the way over here, so which means he only has 1 dot. So I'm going to put our 1 dot there. We're going to bond these two. Now hydrogen is completely done. Happy with 2 dots. Exception to the rule, just wants to look like helium, right? Helium is in his line. Just wants to look like helium. 2 electrons, check. All right, so which means we're going to need to add 2 more H's, because P needs to make a total of 8 electrons, 5 bonds. Oh, sorry, 3 bonds with the 2 extra. That and that. There's a bond. There's a bond. So do you remember what these were called up here? If you said lone pair, you would be correct. Lone pair of electrons, or non-bonding electrons, and each hydrogen has 2, and P has 2, 4, 6, 8. So you're done with that. There's the drawing. The formula is PH3, and the name is phosphorus trihydrogen, but change the ending to "ide", trihydride. This is one of those where you lose a couple of the syllables in the ending. All right, I think that's pretty good for the night. We can stop there, and I'll give you a little bit more difficult ones another time. All right, so good luck. Make sure you ask questions. Tune in if you can to a Google Meet sometime. All right, bye guys. Wait, come on back. Slow it down. Let's just do 2 the other way, just to make sure that you guys can realize just how easy it is to name backwards. All right, so I'll write the formulas from the names. So remember, you're looking for the prefixes, and then you're looking for the elements. And then make sure that you write them in the correct order. So the first one is pentasulfur, heptasilicide, and then dihydrogen monoxide. So if we write these, pentasulfur, so that's like saying 5 S's, and then heptasilicide is 7 Si. Now remember, you don't put the numbers up at the front, they're at the bottom, so really it should look like S5, Si7. All right, and then same thing here, 2 H's, 1 O, and what do you know, if you write that out, oops, almost did it wrong again. It should look like H2, 2 H's, and 1 O. There's your water. Technical term for water is dihydrogen monoxide. All right, happy trails, guys. Good luck.